Now we're recording. That's better. So like I said, chord goes from one side of a circle to the other side. Secant is a line that goes through the circle. So instead of from one point to another point, it goes through the circle in two different points. Now the tangent hits it in one place. And as I was saying, that think of it as a tire on the road. That is the point of tangency. And we need to be able to identify these things because there are specific things that we can go through and do with them. So what we're going to do here is we're going to identify 3 radii and a diameter. Now mind you, radii is used for plural radius, radius is singular. So if I want to identify 3 radii here, what I'm going to end up having is one of them is going to go from N to P. Another one would go from Q to P. Another one still would go from L to P. Now, what would be the diameter? The diameter would just simply be going all the way through from N to Q. So there's our diameter. So what if I wanted to identify 2 chords? Well, one of the chords would be right up here from M to L. So there's one chord. Where would the other chord be? Well, the other chord is going to end up being the diameter. Because all that a chord is from one side of the circle to another side of the circle or another point on the circle. We've got our chords. What about a tangent? So what is the tangent line going to be to this thing? Well, the tangent line is going to be right here. That is going to be ST. Because it's a line, make sure that you identify it as such. And what is its point of tangency? Well, that's just going to be point R. That's all we have to do is just to identify what those bits and pieces are. So, I am going to give you a minute or so here, and I want you to see what you can come up with to answer the question. So, let's see here once. Let's see, Jacob. What would I classify FH as? Oh, radius. Radii would be if there's more than one of them, but radius would be just a singular. So now you got me with the I's. Here we go. R-A-D-I-S. Okay, good. So let's see. That puts us at Logan. What would I list FG as? Okay, so that could be a chord. Is there anything else it could be too? Well, radius to go from the center to the outside, you got to think about it as a bicycle spoke. But this is going from one side to the other through the center, so it would be the, diameter. So let's think about line L. What would line L be for Aaliyah? Line L? Does that look like a bicycle spoke or a bicycle spoke that's broken off? Okay, that's just a line going through it, right? So that's the what? It's the weird word. It starts with an S. Yep, that's the C. Okay. Let's see. So what about line M. What would that be? Hannah. Tangent. Yep. So being able to, when they give you the terms, you got to be able to identify which ones are which. So I'm going to give you a few moments here, and I want you to put these two theorems into your little. So when I take a look at a diameter being perpendicular to a chord, if I have this situation, I know that it's going to bisect the chord and the arc. So if I have that situation, then I know that. It's an if-then idea again. Now, if the diameter bisects a chord, in other words, if the diameter goes through, cuts the chord in half, then I know it's perpendicular. So these two go hand in hand. If I know it's perpendicular, bisects. If it bisects, perpendicular. So when I look at something like this, what would have to be the length of x? 3. Because I know it's bisecting it, because it's a right angle here, that's 3, that's got to be 3. So what would be the angle measure at R? Well, this would have to be a right angle as well, 90 degrees, because this and this identify as those as congruent. It's a chord. So if chord is being bisected, cut in half, it has to be at a right angle. So if I look at this, this looks, other than the fact that it looks like a mess, there's a lot of stuff there. What is it that they want to know? It says a circle show it has a diameter of 14 inches. Chord AB is 8 inches long. How far is AB from the center of the circle? So what they're looking for is this height right here. That's what I've got to find. So by drawing this out, I see what my situation is. I see that I have a right angle here. I see that this is bisected. I know that this is 8, so this would have to be 4. Now, what kind of a triangle do I have there? Right triangle. So that means that Pythagorean theorem, a squared plus b squared is equal to c squared. So that means 4 squared plus h squared is equal to 7 squared. So I've got 16, 49, subtract 16, subtract 16. H squared is equal to 33. H is equal to the square root of 33. And I can use my graphing calculator, and I think I actually have it in there from last hour. Turn that on. Square root of 33 turns out to be 5.7. So I can use that and say that the height is going to be equal to 5.7 inches. But again, this is why we know, Pythagorean theorem. That's why we have to know the relationships, so that if we have a situation like this, we can go through and figure out what things are going to be. So I'm going to give you a couple minutes here, or a moment, and I want you to do B and C. So let's got Hayden. What would be the value of A? And let's see, Tessa, what would be the degree measure for X? Good. So I'm going to give you another moment here, and I want you to put this theorem in. Okay. The nice thing about this, you can use it to find the center on any circle. And you're kind of looking at that. What do you mean? If I got a circle, say I go through and draw myself out a nice And I'd like to know where the center of this is. I can take a random line, go from here down to here. Now remember when we went through and did the constructions for bisecting a segment? Remember doing that? Yes, no, maybe so. If I can bisect that segment, I know where the middle is at, right? Midpoint. So I can find that midpoint. When I find that midpoint, and we talked about how we can do a construction that is perpendicular to it, which actually the line is that we have to use to find the midpoint. So that means I know how to go through and create the line, of course it was straight, that's a right angle here, and it will always go through the center. So I would have to find segments that are the same distance from here to here. That's all it takes. And that's the nice thing about this. So it's kind of an easy little thing to know if you like making circles and finding the center. Of course, just taking a piece of string, nailing it down in one spot and putting a pencil on the other makes really good circles too, doesn't it? But that's what we're driving at with this idea. So I want to prove that the perpendicular bisector of a chord contains the center. Well, it says EF is the perpendicular bisector of AB. So I know that this is going to be a right angle, and that are going to be the same. So I'm supposed to prove that EF passes through the center of P. Well, if EF is a perpendicular bisector of AB, what could I also call EF? Well, since EF is perpendicular bisector, yes, you can get by using those initials only that way, this purpose, okay, of AB, we know that it is the diameter. So which one of these rules tells us that it's the diameter? So that's why you have these in your little book. Which one? Well, isn't that 43.2 if a diameter, oops, that is the other way around. If a diameter is perpendicular to a chord, then it bisects the chord. And if it's bisector, then it has to be a diameter, right? Isn't that what that says? So, by, there we go, theorem 43.1. Do all diameters go through the center? Yeah. And by definition, diameter goes to the center. Now, this is just paragraph proof to go and identify, what's going on with it. You don't always have to be super specific for it. Sometimes a two-column proof works. Sometimes this works out better that I know this, this, and this, and know what the diameter is because of this theorem. So, and I know that by definition, this is going to happen. The idea, again, with the proof, guys, is there a logical argument that takes you from the beginning to the end? Can you justify it because of theorems, definitions, postulates, rules? So, I'm going to give you a couple minutes here, and I want you to take a look at this and see if you can come up with a logical reason why. All right. So, had some time to think about that. So Caleb, we know that we have CD perpendicular to EF that was given to us. What other information do we have based upon what we see in the circle? Okay, so I could go angle M, say angle M, whatever that was, is equal to 90 degrees. So that's definition of perpendicular. What else do we know in there? Is there anything else that you see? Because if I'm supposed to use 43.1, if a diameter is a perpendicular to a chord, then it bisects the chord. What am I supposed to be able to deal with now? Does it seem like we have enough information? Okay. So I know that EF is a chord by definition. What is CD? Radius. Okay. So CD is a radius. And the thing is, that would also be part of the given. Okay. So if CD is on a radius, is it on a diameter? Okay. So CD is on a diameter. Why? Well, that would simply be definition of radius. So I know that it is a diameter. I know that. So do I have any information that tells me that if it's a diameter and it's a right angle to a chord, that it has to bisect? Well, if you go back here, if a diameter bisects a chord other than another diameter, then it is perpendicular to the chord, correct? And it says if a diameter is perpendicular to a chord, then it bisects the chord and its arcs. So, go back. By the way, will that help us anything? It says the perpendicular bisector of a chord contains the center, but we still don't know that it's being bisected yet, do we? I got to prove that it bisects it. So, I know it's at a right angle. I know that it's a diameter. I know that we have this situation. Can I now go and say that because it's perpendicular to the chord, it bisects? And which one of those rules is that? There you go, 43-2. So we can now say that CD bisects EF. Why? Theorem 43-2. There you go. Again, it's kind of difficult to sit there and take a look at this and see what is what. Now I got a question for you here. Could have I gone and said, you know what? I know that this here and this here are going to be the same, correct? Because they're radiuses, right? I know that this thing here is on the same thing. I know that that's a right angle. Could have I used one of my triangle congruence theorems to say, hey, these two triangles are congruent, and then that means that this is got to be congruent to that, right? It's another way of looking at it. Like I said, it's what you see and it's what you're able to justify. So, one final one. I'll give you a few moments here to go and put that one. All right, this is kind of a easy one to deal with. If I've got something that looks like this, looks like a mess again, doesn't it? But let's put in the information that we know. We know that A to P is going to be 5. So that radius is 5. Does that mean this radius is 5? Does that mean this radius is 5? Does that mean this radius is 5? Okay. We are told PE is 3. So if that's 3, this is 3. Are those two triangles congruent? Yeah. Could I use the Pythagorean theorem to find the length of this side? Okay. By the way, what is the length of that side? Remember when I said the hypotenuse is 5, a leg is 3, the other one is a 4, 3, 4, 5. So that's 4, that's 4, that's 4, that's 4, from here to here is 8. So again, knowing all these little rules is what you need. So I'll let you guys get to work on the assignment.